So one way to reduce the amount of carbon dioxide that we're releasing into the atmosphere is to use fuel that's extracted from plant matter or bioenergy, and hence this is either carbon neutral, or if we combine it with CCS, carbon negative as well. So in this section I'm going to talk about various forms of bioenergy that are currently being implemented in the UK. So first of all, the UK signed what's called the 2009 Renewable Energy Directive. And basically this has a binding target of, it's the 320, so it has a binding target of 20% of our final energy consumption coming from renewables by 2020, so it's 20% by 2020. And obviously bioenergy forms part of this mix, and there's kind of a sub-target that at least 10% must come from transportation. The UK's commitment to this, again, gone above and beyond, is 15% with bioenergies. And EU countries have already agreed a new target of 27% by 2030. So, what is bioenergy? Well, bioenergy is a renewable energy generated from materials which have been derived from biological sources. And this can be categorized into what are called generations. So the first generation biofuels, these are conventional fuels that are made from food crops. So, for example, sugar that's turned into ethanol and things like that. Now, there's a bit of a contentious issue with first generation biofuels because obviously we've only got a finite amount of fertile land in the world to grow crops on. And with the world population increasing, we suddenly have to start making choices that are we going to set aside that fertile land to grow crops for fuel, or are we going to set that fertile land aside to grow crops for food? So it's this food versus fuel debate, in that, you know, and if you do take land to use to grow crops for fuel, then you start pushing up food prices, and that has lots of kind of knock-on effects. So there's this kind of as I say, contentious issue, this food versus fuel debate for first generation biofuels. Second generation biofuels kind of gets rid of that argument, because second generation biofuels are fuels that are made up from organic matter that's already fulfilled its purpose. And a good example of this is, for example, biofuel that's made from waste cooking oil. So a lot of the fast food restaurants now converting their waste cooking oil into biofuel that to run their transportation on. Now that's great, that's good. You know, it's the organic matter doesn't have any more use, so we found a second use for it. But the issue with second generation biofuels is that it's limited supply, because you can only obviously the amount of second generation biofuel you can create is linked to the amount of waste material that you're getting. If you start using up all your waste material, then you can't generate any more biofuel. So it's not really a kind of sustainable. Once you've started utilising 100% of that, you can't create any more. So the third generation biofuel tries to increase that again. And what this third generation biofuels are is it's technology where basically generating fuel from oil-rich algae. So algae, which are the microorganisms that live in water, you know, turn the water that green colour. Certain species are quite oil-rich, and there's plants, there's processes now where you can basically grow the algae on these water runs, and all you need is water and the sunlight, and they take the carbon dioxide from the water, and you then remove the water, dry out the algae, process them, and you can extract the oil. The advantage of this is that you know, sort of like for like, you don't need as much area to generate the same amount of fuel from algae as you do from crops. And also, you're not using fertile land. This doesn't have to be done on fertile land. It can be and wherever really. So this is becoming more and more the way to go for its obvious advantages, and we're going to talk about a couple of these in this section. So bioethanol, this is a first generation biofuel. It's produced by fermenting starchy crops, as I said, such as sugar and cane and wheat, and the fuel can be used to generate electricity as well as for transportation. So you might have seen E85 at the pump. That's obviously got the E stands for ethanol. So it's used for transportation, and Brazil is one of the world leaders in this actually. That they've currently producing 700 megawatts from bioethanol in their country. Biogas. So in the UK, this is this is a second generation biofuel, and biogas is generated from anaerobic digestion of organic matter. So what anaerobic means is without the presence of air. So you take your waste material, and that can be anything from food waste to sewage to rubbish, biomass from your bins, and basically tipped into a big tank, and it's bacteria, that's the feedstock for the bacteria, and they munch away at it basically in the absence of oxygen, and they produce a biogas, which is primarily methane, so it's 6% methane, but the rest of it's carbon dioxide as well. And then we can use that, we can burn that in our gas turbines or purify the fuel for other processes. And there are many sources. Some estimates say there's 100 million tonnes of suitable organic material in the UK. And this map here just shows all the various biogas plants there are in the UK that are currently operational in producing biogas. Okay, wood pellets. This is first generation biofuel, so basically using plants or trees to produce a fuel. And what I'm going to present here is Drax, which was one of the UK's largest power stations, is converting from coal to wood pellets. And this has thrown up some interesting challenges actually, and some of them you might not expect. So the wood pellets that they use primarily come from commercial forests, so they're planting the trees as fast as they're cutting them down. And so the advantage is, assuming that they are replanted at the rate they're being cut down, that this process is carbon neutral. But to convert the plant, there's been a number of challenges. Firstly, the pellets need to be kept dry. Now, perhaps counterintuitively, the coal that's burnt in power plants doesn't need to be kept dry. It's basically just stacked up in the yard. It has several advantages. Being outside, the dust is damped down, it's less of an explosion risk. But basically, when the coal goes into the power station, it's not shoveled in like you see, an engineer doing on a steam locomotive. Basically, the coal is ground down extremely finely, to kind of like custard powder or ice and sugar fineness, and it's ejected into the furnaces with steam, and so any moisture that's in there will come off very quickly. So the dampness of the coal isn't an issue in a coal-fired power station, but with wood pellets, you don't have that. They do have that problem. If they get damp, they're not usable, unlike the coal, so they have to be kept dry. So this is one challenge that they had in converting this power station over. They had to create these large covered areas to store the wood pellets. On top of that, the wood pellets only have half the energy density of coal, therefore you need to burn twice the volume. So either you've got to create a larger area, or for your given area you've only got so whereas before you might have had enough area for say 10 days worth of coal, that's only 5 days worth of wood pellets. So that puts a strain on your supply chain then, because you need to ensure that you're getting the pellets in time so you don't run out. So you need a continuous source of the pellets as well, not just good logistics to ensure they arrive on time. And surprisingly, wood, or in particular the dust, is more of an explosion hazard than coal is. There's extra measures that need to be taken to ensure that that there's no stray or static sparks which might cause a serious incident. Okay, so one thing that just wanted to think about this: can we actually get fuel out of thin air? So this is the idea. This is what people are perhaps thinking about doing now. So the idea is that we take water, and obviously you've got to supply some energy, so we add electricity, and we electrolyze use an electrolysis plant to split the water into oxygen and hydrogen. Now we release the oxygen and we take the hydrogen. Then what we do is we send the hydrogen into a reverse shift reactor. And if you remember, we saw a shift reactor when we were talking about pre-combustion carbon dioxide capture. So this is doing the reverse. Rather than generating the carbon dioxide, it's using the carbon dioxide from the atmosphere to basically react with to take out the to generate water, but to create this synthetic gas. So this carbon monoxide and hydrogen is a product of this. Then you can use a fairly standard Fischer-Tropsch reactor to generate whatever fuel you want. So in that as this kind of standard alkane. So you can produce gasoline, diesel, Jet A, whatever. So obviously this requires kind of a large amount of electricity when the water is electrolyzed into hydrogen. But if you the argument is if you build this near the equator, you've got an abundance of solar energy, which is free and you can use. If you build it near the coast, you've got an abundance of water, which is a free source. And also you've got your carbon dioxide in the atmosphere, which is free as well. So the argument is if you do this in the right place, then you could get this to work and kind of generate, as I say, extract fuel out of thin air. So is this fantasy or is it fact? Well, actually, it's already been done. And Audi have already done this. They've created a plant based on the technology that I was showing you on the previous slide that can produce that they've produced 3,000 litres of what they call e-diesel that they've extracted from the air effectively. They claim that the efficiency of this renewable energy to liquid is about 70%. But the question is, can this be scaled up? Can this technology be improved and made more wide scale? And actually, in terms of, we talked about first, second and third generation biofuels, this is being talked about. It's the fourth generation. So basically creating these fuels from solar energy. So, it could be that this e-diesel is the fourth generation biofuel. Okay, I hope you've found this session interesting on the environment. If there's any comments or queries, just let me know. Thank you.